Hello, this is the test corrections for Unit 10, uh, simplifying radicals or solving for special right triangles. Okay, first one, we're just getting practice on simplifying radicals. All right, so we're multiplying radical 2 times radical 10, and then we're simplifying it in its lowest radical form. Radical 2 times radical 10 is radical 20. Okay, and then you have to say, all right, what perfect square goes into 20? What's the biggest perfect square that goes into 20? And that's square root of 4. All right, square root of 4 times square root of 5 is 20. Square root of 4 we know is 2. So we have 2 square root 5 as an answer. Next one, we're multiplying again. We multiply the outsides, 15, 3 times 5, and then the insides. Rad 2 times rad 6 is rad 12. Now we could simplify rad 12, again 4 and 3, and you get 2 rad 3. Alright, so we have 15 times 2 rad 3, and you get 30 rad 3. Next one, find the missing side length of the right triangle. Okay, write your answer in radical form. Okay, if we want to find the missing side length, then we have two sides to a right triangle. Always think of the Pythagorean theorem. So we have our legs here, and then we have our hypotenuse. So it's going to be 1 squared plus 3 squared equals x squared. 1 plus 9 equals x squared. X squared equals 10. We are going to square root both sides to get 10 by itself. And we get x equals the square root of 10. Okay, is there a perfect square that goes in the square root of 10? There is not. So we leave it as it is. Next one, here's our two legs. And then here's our hypotenuse. So we have x squared plus 6 squared equals the square root of 41 squared. Oh, x squared, 36. Now square root of something squared, they cancel each other out, so you're just left with 41. Subtract 36 on both sides, and we get x squared equals 5. Square root, x equals the square root of 5. Alright. Number 5 and 6, we have to find the value of x in the 45, 45, 90 triangle. Okay, and we know that the ratio is one side length to one side length to whatever that side length is times the square root of 2. So we have x and x for our two legs in the 45, 45, 90. We know that the side square root equals 3 square root 2, so therefore s equals 3. Okay, so if the side s equals 3 and x equals s, okay, then we know that x equals 3. Same thing over here. Okay, we have s square root 2. So we have our two legs are 3 square root 2, 3 square root 2, and x is our side square root 2. Alright, so if s equals square root 2, 3 square root 2, then we're going to take this and plug it in for s to solve for x. So 3 square root 2, plug that in for s, times the square root of 2. Alright, and that's what x is going to equal. Well, the square root of 2 times the square root of 2 is just 2, because that's the square root of 4, and we know the square root of 4 is 2. So you get x equals 6. Okay. The next one said show the triangle is 45, 45, 90. We don't have to do that. All we have to do is something similar to 5 and 6. Okay, just solve for x. Alright, so we have again side square root 2. Alright, we don't know these two sides, but we know that side square root 2 is the same as 6. right here. So s square root 2 equals 6. Solve for s. Get s equals 6 square root 2. Can't have a radical in the denominator, so we multiply by what's there, and we get 6 rad 2 over 2, which is 3 rad 2. Okay, so s equals 3 rad 2. Okay, number 8. Much similar. Again, we need to find x. All right, and it's very much the same. Again, s square root 2 is going to equal 10, that ratio. So if we find s, we'll be able to find the length of this side here. S equals 10 square root 2 times square root 2 times square root 2, and we get 10 square root 2 over 2, and we get 5 square root 2. Alright, number 9 and number 10. Alright, we have 30, 60, 90 right triangles. Okay, and we know the ratio is s for across 30, and then s square root 3 for across the 60, and then the ratio for across the 90 is 2 times whatever s equals. Okay, so in this case we know that s equals 2, so across from the 60 is 2 rad 3, and across from the 90 is 2 times 2. Alright, so x equals 4. Okay, same thing here. 30, 60, 90. Here's our ratios. Alright, across from the 30 is 14, so s equals 14. Alright, so we plug in s for across from the 60. You get 14 square root 3. And then across from the 90 is 28. We don't have to solve that. We know that x equals 14 square root 3 because it's across from the 60-degree angle. Next one, we have to solve for x and y. Okay, across from the 30 is x, so s is the same as x. Across from the 60 is y, and across from the 90 is 20. Alright, so we know that 2s equals 20, so s equals 10 divided by 2. Alright, if s equals 10, then across from the 30 is 10, and across from the 60 is 10 rad 3. So x equals 10, y equals 10 rad 3. Same thing over here. We got s square root 3, 2s for our ratios. We know across from the 90 is 38. Alright, so 2s equals 38. We get s equals 19. Alright, so across from the 30 is 19, so y equals 19. And across from the 60 is 19 rad 3. So x equals 19 rad 3. (13, 14, 15, and 16). We have to find 13 and 14. We have to find tan A and tan B as fractions in simplified form. So tan of the angle, okay, tan theta, the angle, or you could use a lowercase a for the angle, is opposite over adjacent. Okay, so we look at A, so tan of angle A is opposite over adjacent, so 30 over 16. And we're going to simplify this fraction. We get tan A is 15 over 8. Tan B, B is here, so opposite is 16. Adjacent is 30. Okay, simplify that. We get tan B equals 8 over 15. Alright, same thing, number 14, tan A is here, so opposite over adjacent, 80 over 39. Alright, we can't simplify that, so there's your answer. Tan B is here, so opposite over adjacent, again, 39 over 80, can't reduce it, so it's tan B equals 39 over 80. That's all you had to do for those two. Alright, number 15 and 16, find the value of x in simplified form. Okay, so we have the angle measurement, we have one side, okay, we have to find the other side, the other leg. Alright, from the angle measurement we know the opposite and adjacent. Alright, and the ratio we would use is tan. So tan of the angle, in this case it's 22, equals opposite 15 over adjacent. Excuse me. Alright, now all we have to do is solve for x, and the quick way to solve for x is just swap these two. X equals 15 over tan 22. Number 16, opposite, adjacent. So tan again, tangent 61 equals opposite, which is x, over adjacent, which is 9. Okay, solve for x, multiply both sides by 9. You get x equals 9 tan 61. Alright, and you didn't have to calculate it, you could just leave it in that form. Alright, similar to the tangent part, we had to do sine A and cosine A. So sine A, sine is opposite over hypotenuse, and cosine of the angle equals adjacent over hypotenuse. So sine A is here, opposite, and hypotenuse, 36 over 39. Reduce it by 3, 12 over 13. Cosine A, adjacent, hypotenuse, 15 over 39. Again, both are divisible by 3. So you get cosine A equals 5 over 13. 18, sine A is here, opposite, hypotenuse, 17 over 25. Can't reduce it, so leave it as it is. And then cosine A, adjacent, hypotenuse, 4 rad 21 over 25. Can't reduce it, leave it as it is. Number 19, solve for x and y. We have the angle. Alright, if we want to solve for x, we know we have the opposite and hypotenuse, so we'd use sine. Sine of the angle equals opposite over hypotenuse. Solve for x, so we divide by 13, or multiply by 13 on both sides. X equals 13 sine 65. Alright, now if we want to find y, we have our angle and the adjacent side and the hypotenuse. So sine 65, not sine, cosine, adjacent over hypotenuse, 65 equals y over 13. Multiply both sides by 13. Alright, so y equals 13 cosine 60. All right. View the next.